Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Dr. Ibrahim. My name is Nashita Mutiara Gandana, and I'm a representative of Group 4. And today we're going to be presenting our final presentation on sign language detection for our artificial intelligence project. So here is our project technical flowchart. Firstly, these are the processes that we have undertaken to ensure the output of our project. Firstly, we do data collection. After that, we will do data training via teachable machine. Then after we finish training it, we will test our AI model to see whether its prediction is accurate or not. If it is accurate, above 75%, we will then continue to export our model. If it is not accurate, we will have to retrain and we have to recollect our data. So after we export our model, we will then be putting it into Google Colab, and then we can predict our output or our class, depending on what letter is being projected onto the system. All right, so these are the steps in which we have taken. Firstly, to initiate our project, we assembled a personalized data set centered around 26 letters according to the American Sign Language Standard. We then curated a substantial collection of diverse images encompassing the range of hand gestures for each letter, A all the way until Z. So we use Teachable Machine, which is basically a platform that we use to be able to facilitate us in the process of gathering and categorizing our data into 26 distinct ASL alphabet categories. This was achieved either by uploading our own data, but mostly we captured it live using a webcam. All right, so during the training process, we employed a learning rate of 0.001, which governs the speed at which the model adapts its parameters. This lower learning rate strikes a balance between accuracy and efficiency. To refine the model's performance, we trained it for different numbers of epoch. So this iterative training allowed the model to fine-tune its parameters and enhance its prediction capabilities. By leveraging a large data set, selecting an appropriate learning rate, and conducting extensive training, our goal was to improve the model's proficiency in classifying ASL letters, which is what we did in the dataset training. Following the training phase, we did the model testing on the teachable machine platform itself. So we move on to the testing model by examining its output and prediction percentage for each categorized class. So this step allows us to assess the model's performance, ensuring its accuracy and also its reliability. So once we find its accuracy is higher than 70%, we will then move to exporting the model. So once we have obtained satisfactory results from the model testing, we will export it to Google Colab for additional testing. So this crucial steps enables us to validate the model's performance and assesses its effectiveness in real-world situations. By conducting further evaluation on Google Colab, we can ensure that our model performs well beyond the training phase and meets the requirements of practical applications. All right, so this is our training phase. So the export model functionality provides us with an opportunity to evaluate the model's performance in real-world scenarios by accurately recognizing and classifying ASL gestures. So through visual analysis of the predicted letter and confidence level, we can see here from the output, this is the letter B. And we have put 273 image samples with an epoch of 60 and a learning rate of 0.001. So once we're model testing here, we can see that the system has accurately predicted that the letter being shown here is the letter B. So we can say with confidence that the testing phase plays a critical role in validating the model's performance, ensuring its reliability, and verifying its suitability for practical applications. So here are the results that we obtain from after testing the model. We will then put it out onto Google Collaboratory. And we can see here that for these three different outputs, the letter W, the letter K, and the letter H with varying result of confidence score. For example, here we put the letter W and we receive a confidence score of 90%, 99%. Here for the letter K, we receive a confidence score of 94%. And for the letter H, we receive a confidence score of 76%. So for the future work, we see that firstly, the evaluation metrics such as accuracy and loss calculation are improved to more accurately evaluate the performance of the model during training. So this is one of the things that we have to improve in the future work. Secondly, further training, fine-tuning of the model, and expansion of the data set can be used to improve the prediction accuracy of the model. And thirdly, to evaluate the impact of integrating Raspberry Pi into the project, looking at factors such as compatibility of system components and determine whether Raspberry Pi is a viable hardware option. Because firstly, when we ran the output and exported the model, we find that using Raspberry Pi to do it again is a redundant process and it's not very compatible of our system components. So in conclusion, this project aimed to develop an AI model for the ASL letter gesture recognition. So the methodology involves collecting a diverse data set and training the model using teachable machine. Future work should focus on improving prediction accuracy, evaluating the Raspberry Pi integration, and implementing accurate evaluation metrics. These enhancements will optimize performance and enhance communication for the hearing impaired community. That is all for our group presentation. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.